Welcome to The Explainer. Okay, let's talk about the tech that's powering just about everything these days. Tools like ChatGPT. We're talking about large language models, or LLMs. And today we're going to pull back the curtain and see how they actually work. I mean, you've probably seen them do some pretty amazing things, right? They can write stories, solve really tough problems. They can even debug computer code on command. So the big question is, how on earth do they do it? Okay, check this out. What's really wild here isn't just that it fixed the code, it actually explains the bugs, right? It tells you why it was broken in the first place. That that feels like real intelligence, doesn't it? Like it's actually reasoning through the problem. But is it really thinking? Is it conscious? Well, the answer is simpler and, frankly, a lot stranger than you might think. And to get there, we first have to look at how we interact with these things. All right, let's get into how we speak the language of AI. See, the main way we control these models, our remote control, if you will, is something called a prompt. And a prompt is so much more than just a question. It's the key that unlocks the model's potential. And this is a brilliant example of just how powerful prompting is. Look at the left side. You ask a simple question, you get a simple, and in this case, totally wrong, answer to a basic math problem. But now, look at the right. By showing the model how to think it through step by step, it not only gets the right answer, it shows its work. It's a night and day difference. Yeah, this technique has a name. It's called chain of thought prompting. And it was a huge breakthrough, really, in figuring out how to get these models to tackle more complex reasoning. So what's so cool about this is that we're basically programming the model on the fly, just with our words. Whether we give it 0 examples, that's called zero shot, or maybe 1 or even a few examples to learn from, we're shaping its response in real time. Okay, so now we know how to use the remote control. Let's pop the hood and see what kind of engine we're actually dealing with. So when you get right down to it, what is this thing actually doing? What's the core secret? For all the magic and all the mind-blowing complexity, the secret behind it all is surprisingly simple. It's just predicting the next word. Seriously, that's it. At its core, an LLM is just a giant, super-powered autocomplete. Now, this basic idea isn't even new. It's a statistical task called language modeling, and it's been around for decades. The model just looks at a chunk of text, and then it calculates the odds for what word, or more accurately, what token, should come next. And a token can be a whole word or just part of one. Okay, hold on. If it's just a fancy autocomplete, how does it debug code or write a sonnet? Well, that's where the 2 secret ingredients come in. Just absolutely massive scale, and a process called alignment. First up, incredible scale. We're talking about training these models on a dataset that is basically the size of the entire public internet. And here's the thing. When you force a neural network to get really, really good at predicting the next word across that much text, it can't just learn grammar. It has to start learning about the world itself, facts, concepts, relationships, just to make sense of it all. And just look at the growth here. We're talking about the number of parameters in these models. You can think of a parameter as like a tiny knob the model can turn to fine-tune its understanding. And we went from millions of these knobs to hundreds of billions in just a handful of years. The leap is just staggering. This insane growth led researchers to discover something called scaling laws. And it's basically a predictable rule. As you make the models bigger, give them more data, and train them with more computers, they just get better. And not just better, they start developing new skills all on their own. But okay, a bigger model isn't automatically a better model, at least not for us humans. A raw, pre-trained model can be, well, a bit wild and unhelpful. And that's where our second key ingredient, alignment, comes into play. I love this analogy. Pre-training, the scale part, is like forcing someone to read every single book in the world's biggest library. They'll be incredibly knowledgeable, but maybe not very pleasant or useful to talk to. Alignment is like sending that person to finishing school. It's a process where humans give the model feedback, teaching it to be helpful, to be safe, and crucially, to actually follow instructions. Okay, so let's put it all together. How do we get from this simple idea of predict the next word to something that can hold a conversation and feel, well, intelligent? So let's recap the whole journey. At the very bottom, it's not thinking in the way we do. Its core job is just predicting the next word. But that simple function becomes incredibly powerful when you apply massive scale,
trillions of words of data and billions of parameters. Then you make it actually useful for people through alignment, fine-tuning it to be helpful. And somehow, out of all that, these complex abilities like conversation and reasoning just emerge.
And that really leaves us with one last kind of mind-bending question. If these things are just incredibly complex pattern predictors, what does it mean when they start showing emergent abilities? Skills that nobody ever programmed into them? When they suddenly learn to do math, or write code, or reason about the world, what does that tell us about the nature of intelligence itself?